Good day, everyone. Today, we are going to present experiment number 4, entitled Determination of Specific Gravity and Water Absorption of Aggregates. This experiment aims to determine the specific gravity and water absorption of both fine and coarse aggregates. These tests are important because aggregates are one of the main components of concrete, and their properties greatly affect the quality, durability, and strength of construction materials. Specific gravity helps determine the density of aggregates compared to water, while water absorption measures the amount of water that aggregates can absorb through their pores. These properties are essential in designing concrete mixtures and evaluating the condition of aggregates used in engineering projects. The main objective of this activity is to determine the specific gravity and water absorption of aggregates. At the end of the experiment, students are expected to know how to determine the specific gravity and water absorption of both fine and coarse aggregates. The activity also helps expand knowledge in applying these concepts to other laboratory experiments and engineering applications. In addition, students are expected to develop proper laboratory techniques and practical skills that can be applied in professional engineering practice. The materials used in this experiment include gravel, sand, and potable water. The equipment used are the following: sieving pan, absorbent cloth, digital weighing scale, container, cylindrical metal measure, pycnometer, oven, sieve, tamping rod, density basket, sand cone apparatus. These tools are important in obtaining accurate measurements and ensuring proper laboratory procedures. This experiment helps students understand the behavior of aggregates by measuring their specific gravity and water absorption. Specific gravity measures the density of aggregates relative to water. It gives information about the compactness and suitability of aggregates for construction applications. On the other hand, water absorption indicates the amount of water an aggregate can absorb. Aggregates with high absorption may affect the water-cement ratio of concrete mixtures, which can influence the strength and durability of concrete. For fine aggregates, the experiment uses a pycnometer to determine the bulk-specific gravity and apparent specific gravity. For coarse aggregates, the experiment involves soaking the sample, bringing it to saturated surface dry condition, and measuring its weight in water using a wire basket. The gathered measurements are then used in formulas to determine the specific gravity and absorption values of the aggregates. For the fine aggregate procedure, approximately 500 grams of sand sample were first weighed using a digital scale. The sample was then immersed in water for 24 hours to allow absorption. After soaking, excess water was carefully removed, and the sample was spread on a flat surface for drying. The sample was stirred continuously to achieve uniform drying. Next, the sand cone apparatus was used to determine the saturated surface dry or SSD condition of the sample. The sample was placed into the mold and tamped 25 times. The mold was filled in layers, and each layer was compacted properly. Once the mold was removed and the sand slightly slumped while maintaining its shape, the sample was considered to be in SSD condition. The SSD sample was then weighed. After that, the pycnometer was filled with water and weighed. Part of the water was removed, and the SSD sample was placed inside the pycnometer. Additional water was added, and the pycnometer was agitated carefully to remove trapped air bubbles. The pycnometer was then filled to its calibrated level and weighed again together with the sample and water. Finally, the sample was removed and dried inside the oven at 110 degrees Celsius until a constant weight was achieved. For the coarse aggregate procedure, approximately 4,000 grams of gravel sample were weighed. The sample was soaked in water for 24 hours. After soaking, the gravel was removed and rolled in an absorbent cloth until all visible surface moisture was removed. At this stage, the aggregate reached the saturated surface dry condition. The SSD sample was then weighed. Next, the sample was placed inside a wire basket and submerged completely in water to determine its weight in water. After weighing, the sample was removed from the basket and dried inside the oven at 110 degrees Celsius until a constant dry weight was achieved. The measurements obtained from the experiment were then used to calculate the bulk specific gravity, apparent specific gravity, and water absorption of the coarse aggregate. In conclusion, this experiment helped determine the specific gravity and water absorption of fine and coarse aggregates through proper laboratory testing procedures. The activity improved our understanding of aggregate properties and their importance in concrete production and construction materials testing. The experiment also allowed students to apply laboratory techniques, perform accurate measurements, and understand how aggregate behavior affects engineering applications. Overall, the determination of specific gravity and water absorption is essential in evaluating the quality and performance of aggregates used in construction. Thank you for watching.